this time we are starting section 2 of science, which is all about the stars. And the first couple videos here in this section are going to go over how we measure the distances to stars and how we also measure what stars are made of. So first off, what are stars? They are massive power generators that recombine nuclei to release energy through, I believe, both nuclear fusion and nuclear fission. And so the light from the sun is also a product of nuclear reactions that occur in the sun's core. And over the course of millions or possibly even billions of years, stars are born, evolve, and die. So let's talk about how we get the distances to stars. And first off, the observable universe contains 10 to the 21 stars, tens of sextillions of stars. And that's just the observable universe, which the observable universe is just all the light that has come to us since the beginning of the universe, which also helps us kind of plot how old we think the universe is. And so one of the major ways we measure distances to nearby stars is through parallax. So parallax is actually something that you experience on Earth with Earth objects. So we see that objects will shift their position relative to a background depending upon where you are as an observer, right? And so we can also apply this to stellar objects, right, to celestial bodies. And so when we see the position of a star, we are able to locate it due to its relative location to other stars. And so what happens is that nearby stars will appear to shift back and forth relative to the other stars as Earth revolves around the sun, and this collectively is known as the stellar parallax. Okay, so as we see the Earth orbit around the sun, again, 1 astronomical unit, we then are able to see a near star, right, a theoretical near star, which is 1 parsec away, right? And then based upon the kind of background of distant stars, right, we're able to measure how far away those stars change over the course of 1 astronomical unit, all right? And so by taking the angle of the distance, as far away as the star goes to the star as we see it at any given time, right, that gives us a parallax angle. And again, for a 1 parsec star, well, not yet, I haven't talked about this yet, but with the 1 parsec star, right, the angle is going to be 1 arc second, right? So hopefully that helps a little bit, that little image. We'll come back to it properly here. So the distance to a star is determined from its parallax angle, which is 1/2 the apparent change in the angular position of the star, which again, 1/2, right? So the apparent change, right, but cut in half, right? Because then we have the original distance, and then we have 1 original place, and then as we orbit the sun, right, we're kind of seeing it go both maximums, right? Okay. So parallaxes tend to be very, very small because the distances to stars are very, very vast. The standard unit of measurement for stellar parallax is what are called arc seconds. And 1 arc second is 1 to 1/3600th of a degree, right? So that is very, very, very small. The parallax of the nearest stars are even smaller than this, right? They're less than 1 second. And so we kind of create this imaginary star whose parallax is exactly 1 arc second. And that imaginary star is 1 parsec away, which again is right here, as we can see in this image. Okay, and so parsec stands for parallax in arc seconds. And so 1 parsec equals 31 trillion kilometers, or 19 million miles, which introduces my least favorite aspect of this resource, is that they put everything in both kilometers and miles, which means you possibly have to memorize both of them, so that's great. Or at least memorize. If you just memorize the conversion, I think that's probably easier. But 1 parsec also equals 3.26 light years. And the formula for the distance of a star in parsecs is 1 over parallax, which makes sense because when the arc second parallax is 1, the parsec distance is also 1. So stellar parallax decreases as the distance to a star increases, which again makes sense, right? Because we're measuring the distance of how far it shifts, right? The closest star to the sun is Proxima Centauri, which has a parallax of 0.77 degrees. The largest known stellar parallax, which again, largest known stellar parallax makes sense because it is the closest star. And so 1 over 0.77 arc seconds is 1.3 parsecs, or 4.3 light years, or 40 trillion kilometers away. And they did not give you the miles on this one, which is nice, but you still might need to know that anyways. Who knows? Parallaxes can be measured to about 0.01 arc seconds with today's instruments, which is a distance of 100 parsecs, which is pretty good. That's not bad. Or that's how far out we can measure them. What I said didn't make sense for a second there, right? But when we think about the further away a star, the smaller the angle, right? It just kind of makes sense, because if there's a star up here, right, then its apparent change is going to be much smaller, right? Okay. So only a small fraction of visible to the eye stars are within this distance or have accurately measured parallaxes, and so because of that, we have to create indirect methods to determine the distances to most stars beyond 100 parsecs. So, this only covers a very small amount of stars, but it does cover, a decent chunk of stars. But there are, as we said, 10 to 21 stars out there, at least in the visible universe, observable universe. And astrometry is the measure of positions, parallaxes, and motions of stars. And one of the leading astrometry tools is Hipparcos, or was Hipparcos, which was launched in 1989 by the European Space Agency, operating until 1993. And it was the first space experiment for precision astronomy, or astrometry, and it stands for High Precision Parallax Collecting Satellite. The other thing is that the Hipparcos honors the Greek astronomer Hipparcos, who used parallax to calculate the distance between the Earth and the Moon all the way back in 120 BCE. And Hipparcos is able to collect precise measurements of 118,200 stars. That's a lot. It's also not a lot, because there are tens of sextillions of stars in the observable universe. We did have a follow-up mission to Hipparcos known as Gaia, launched in 2013, presumably still around, right? So that's going to do it for this video. A little quick hit about how parallax works and what it is and the history of it and all that. In the next video, we will cover spectral lines and spectroscopy. But thank you guys so much for watching. I will see you in the next one.